Hello, hi. GSLV-F16 NISAR mission was successfully lifted off yesterday, July 30. From my majestic liftoff to the flawless separation, witness the full journey. Here you can watch the spectacular moments of NISAR launching aboard GSLV-F16 and its precise separation capture on board, a milestone in global space collaboration for ISRO and NASA. Okay, coming into the details. NISAR stands for NASA ISRO Synthetic Aperture Radar Mission. The main objective of the mission, before going to objectives of the details of the mission, the separation is confirmed, each stage precise, Cryo engine and Cryo stage performance flawless. GSLV-F16 delivered NISAR to orbit. Okay, coming into the objective. NISAR is first of its kind mission jointly developed by ISRO and NASA. It is an L and S band global microwave imaging mission with capability to acquire fully polarimetric and interferometric data. The unique dual-band synthetic aperture radar of NISAR employs advanced novel SweepSAR technique, which provides high resolution and large swath imagery. NISAR will image the global land and ice-covered surfaces, including icelands, sea ice, and selected oceans every 12 days. NISAR mission's primary objectives are to study land and ice deformation, land ecosystems, and oceanic regions in areas of common interest to the US and Indian science communities. NISAR mission will help to measure the woody biomass and its changes, track in the extent of active crops, understand the changes in wetlands extent, map Greenland's, Antarctica's ice sheets, dynamics of sea ice and mountain glaciers, characterize land surface deformation related to seismicity, volcanism, landslides and subsides and uplift associated with changes in subsurface, aquifers, hydrocarbon reservoirs, etc. Coming into the spacecraft configuration, the spacecraft is built around ISRO's I3K structure. It carries two major payloads via L and S band synthetic aperture radar (SAR). The S-band radar system, data handling and high-speed downlink system, the spacecraft and the launch system are developed by ISRO. The L-band radar system, high-speed downlink system, the solid-state recorder, GPS receiver, the 9-meter boom hosting the 12-meter reflector are delivered by NASA. Further, ISRO takes care of satellite commanding and operations. NASA will provide the orbit maneuver plan and radar operations plan. NISAR mission will be aided with ground station support of both ISRO and NASA for downloading of the acquired images, which after the necessary processing will be disseminated to the user community. The data acquired through S-band and L-band SAR from a single platform will help the scientists to understand the changes happening to planet Earth. Here are the major mission configurations and joint work shared responsibilities. Mainframe bus, I3K structure with approximately 2,400 kg of liftoff mass, 70-volt bus, 3-axis stabilized spacecraft, and coming into the imaging payload, dual frequency L and S-band synthetic aperture radar, L-band SAR from NASA, S-band SAR from Space Applications Center ISRO, and large size 12-meter diameter common unfurlable reflector antenna mounted on deployable 9-meter boom. Approximately 240 km observable swath with 5 to 100 meter resolution. Imaging payload. These are related to imaging payload. Free and open data policy. Orbit. Sun synchronous polar 6 p.m. Orbit altitude 747 km circular. Inclination 98.405 degrees. And the launcher vehicle is GSLV Mark II with 4-meter payload fairing. Mission life is 5 years. Coming into the realization of NISAR, the complex payloads and mainframe systems have been designed, developed, qualified and realized over a period of 8 to 10 years. The S-band SAR and L-band SAR were independently developed, integrated and tested at ISRO and Jet Propulsion Laboratory NASA respectively. The Integrated Radar Instrument System IRIS, consisting of S-band and L-band SAR and other payload elements, were integrated and tested at JPL NASA and delivered to ISRO. Mainframe satellite elements and payloads were assembled, integrated and tested at URSC, UR Rao Satellite Center, ISRO. NISAR mission phase. NISAR mission phase can be broadly classified into launch phase, deployment phase, commissioning phase and science phase. Coming into the launch phase, NISAR will launch on board GSLV-F16 launch vehicle on July 30, which is yesterday, 2025, from ISRO's Satish Dhawan Space Center, also referred to as Sriharikota High Altitude Range, SAR, SHAR, located in Sriharikota on the southeast coast of the Indian Peninsula. Now, the development phase. NISAR hosts a 12-meter diameter large reflector which shall be deployed in orbit 9 meter away from the satellite by a complex multi-stage deployable boom designed and developed by Jet Propulsion Laboratory, NASA. Commissioning phase. The first 90 days after launch will be dedicated to commissioning or in-orbit checkout, IOC, the objective of which is to prepare the observatory for science operations. Commissioning is divided into subphases of initial checks and calibrations of mainframe elements, followed by Jet Propulsion Laboratory engineering, payload, and instrument checkout. Coming to the science operations phase. The science operations phase begins at the end of commissioning and extends till end of mission life. During this phase, the science object will be maintained via regular maneuvers scheduled to avoid or minimize conflicts with science observations. Extensive calibration and validation activities will take place. The observation plan for both L and S-band instruments, along with engineering activities, for example, maneuvers, parameter updates, etc., will be generated pre-launch via frequent coordination between Jet Propulsion Laboratory and ISRO. Okay, you can have a look at the video now. Have a nice day. Thank you.
Five, 4, 3, 2, 1, 0.
All L40 engines generating nominal thrust, S139 motor ignited.
Repeat the tracking.
P1 tracking.
Plus 10 seconds.
Liftoff normal.
MFCL tracking. 15 seconds. P2 tracking. Plus 20 seconds.
First stage performance normal.
Plus 20